All right. Okay, let's begin. All right, welcome back, everyone. Really glad to have you guys here today. Hope you're all doing well. So, today we're going to be exploring Google Cloud, all right? So, this is an introduction to cloud computing, specifically the Google Cloud. So, our objectives for today, we're going to discuss what the cloud is and why we should use it. And also, we'll be going through some of the basic concepts in cloud computing, as well as understanding how to navigate the Google Cloud Console. And then at the end, we'll also show you guys how you can become cloud certified. Okay. Joel?
All right, so good afternoon, everyone. So just like a brief intro to cloud, most of us or all of us should already know what it is. It's basically a way to rent compute power and storage from a data center. So we have cloud computing platforms like Amazon's AWS, Microsoft Azure, and then what we're learning about today, which is Google Cloud Platform. And just as a uh, like a continuation, we use Firebase, or we have used Firebase in some of our projects. And Firebase is based on Google Cloud, or Google Cloud backs Firebase. So some of our projects are actually using Google Cloud resources, but we're on the free tier. And now to introduce our speaker. All right, so today we have with us Mr. Winston Douglas. He's a customer engineer and data management expert with Google Cloud. He is widely regarded as a go-to resource for data management expertise in the USA and Canada. And in his role at Google, he guides customers in migrating their data and databases to the cloud and engineering database solutions. So he deals with how to design modern applications to run on scalable and globally distributed databases on the Google Cloud platform. Winston is a graduate of the University of the West Indies. He did a degree in computer science and mathematics, and he's a certified Google Cloud data engineer, cloud architect, and Oracle database administrator, among other things. And he also attended Calabar High School. And with that, I hand over to Mr. Douglas.
Thank you. Thanks, everyone. And yeah, it's a pleasure to, be here to spend some time with you today to discuss cloud in general and Google Cloud in particular. Before I go any further, Sean, would I be able to share my screen? The share button is currently grayed out for me right here now.
Oh, wait, let me stop sharing first.
Okay, awesome.
Okay.
All right. Share entire window tab. Where is it? I think I have too many tabs here. Still. All right, let's do the window thing instead. Okay, that should work. Okay, there we go. Okay, can you see my screen?
Yes.
Yes.
Okay, awesome. All right, so As a previous speaker mentioned, I work with Google Cloud. I've been with Google for the past 3 years. I'm in this role. And one of the good things or cool things about working at Google is that you can assume different roles from 1 year to the next, or as you see fit for your career, you can pursue different roles or avenues, right, to achieve your goals. So I've been lucky enough, right, to have been in about 3 or 4 different roles since joining Google. um, I live in Toronto, so when I joined, I worked with the Canadian Google Cloud team, and worked with a lot of primarily Canadian customers. So when you think about Shopify, for example, or Scotiabank, or if you're familiar with the Canadian marketplace, TELUS, and global supermarket, well, not global, but a large retail supermarket chain in Ontario called Loblaws. Right, these are some of the companies that I worked with back then. And then I, let's say, graduated to a different role, which served the entire North America region. So in this role that I'm in now, right, and it has evolved and changed in some ways in the last 2 years since I joined. I support customers in both the US and Canada, right? So it's a North America role. And we have a large team of experts in data analytics, AI, ML, data management, SAP even. So if you want to run SAP on Google Cloud, infrastructure. So guys who specialize in networking, storage, compute, application modernization. These are guys who specialize in building applications using App Engine. Um, you mentioned Firebase, right? And Kubernetes engine and so forth. So the role in is diverse as you look at it across the years, right? I get exposed to a number of different Google Cloud technologies, but my passion, right, and what I really love is the data aspect of it. So almost anything related to data, right, I really enjoy working with. Um, Data engineering is one thing, that involves basically building pipelines, right, and helping customers move data from one source to the other in order to build like data warehouses or big data solutions. And then you have data management, which is deploying those large applications, like global scale applications for companies like Walmart and Walmart website. These are applications that you can access almost anywhere in the world. They run on databases that can scale globally and scale up to petabytes, right? And they need people like myself who understand these databases and the capabilities to help them with that transition and deploying those applications on those databases. So that's kind of where I am now, working primarily with the operational databases. We're not going to cover Cloud Spanner today, but that's one of my favorites. Cloud SQL is another one where we run MySQL Postgres within the cloud in a managed environment. Then we have Bigtable that supports some of our services like Gmail and ads and search, just to name a few. And yeah, and a lot of the services that kind of act like glues, right, to those databases. So things like data migration service, for example, which help you to replicate data from one source, AWS, to Google if you want to move your database from on-prem or another cloud into Google Cloud. That said, let me carry on with the agenda here. So, based on, what you shared with me earlier, and, discussions with Sean, this is the agenda that I have put together for today. So I'm going to cover value of cloud computing. As a previous speaker noted, you probably are mostly already aware with what cloud computing is. So I'm taking a slightly different approach to it in terms of how we look at it and what it solves for. So, but yeah, I'm not going to spend too much time on description. And then I'm going to talk a little bit about the cloud infrastructure as well, and some of the basic components, some of the services that you need to think about when it comes to cloud. Popular cloud providers, I'll touch on that a little bit, and what differentiates Google Cloud from other cloud providers. Regions, zones, and points of presence. So that's basically the networking and the data centers that goes into making up Google Cloud. And then I'll go through some of the GCP services. Now, these are just some of the services that we'll talk about today, right? IAM compute, if we have enough time. Yeah, no, I think I covered everything here. But yeah, I mean, if there's something else that you want to talk about, we can add it as we go along if we have time. But keep in mind that this is just a really small subset of all the services that Google provides today. What you don't see here are things like Cloud Spanner, which I mentioned earlier, Bigtable, BigQuery, Kubernetes Engine, App Engine, and I could go on and on. That said, right, if at the end of this we want to, have another session where we kind of focus in on specific topics or services, right, I'll be happy to work with you to do that as well. You might be interested in AI/ML, for example, or some people are interested in that, or maybe just even from the perspective of how you integrate AI/ML into your applications. Right, and we have experts, within my group as well that I could probably ask to come in and have a discussion on that. So if we're okay with that agenda, I'm going to proceed with that for now, and feel free to chime in at any time and ask questions. Right, so we can all stay awake and make a discussion out of it versus me just talking to you. All right, so what value does cloud computing bring? And what I'll do is I'll start out by describing it like this. So if we go back 10, 20 years, right, before the cloud was pervasive or common in our language, right, and how we speak about technology today, we had to deploy servers in data centers in order to build out and bring to production a new application. So we needed a server for database. We probably needed another server to run batch jobs. We needed another server to run your applications, your web tier, your application tier, and so forth. However, the problem with that, as you look at this screen here, if you can see my arrow, is that on day one, so on your x-axis here is time, and on your y-axis you have capacity in terms of the capacity that you have to have available on those servers or that you have to purchase. What the red line depicts is how much capacity you need at a certain point in time. So over here, where the blue line meets the red line is where you estimate that, the capacity requirements, your capacity requirements would grow at a certain point in time. It became very common after a while for people to capitalize or estimate or forecast for 2 to 3 years, because in the technology world 2 to 3 years, anything longer than 2 to 3 years becomes you literally have to be Nostradamus to know what's going to happen then, because technology is changing so fast. So for the most part, most people would, and again, this is even more recently. Back then, we would probably even try to estimate for 5 years, right, hoping that our applications and our servers and technology would last that long. The problem with this approach, however, right, is that you have to pay for all of that capacity upfront, up to the red line, from day one. So from day one, you're not using most of your server. They're just sitting there idle most of the time. You probably, peak to about 10%, 20% utilization in the, during the day or at 5 o'clock in the evening. Then at night, they're idle again, doing nothing, right? But you need that capacity because you don't want to have to keep buying servers every time that you need, your application demand grows, right? Or your application requirements grows. So you buy enough that will last you, a good amount of time, right? And that, again, not too much, right? Because you don't want to overspend either. Anyway, that yellow portion over a period of time becomes unused capacity, and it ends up being money wasted. Think about the Jamaican minivan, for example, right? You buy a minivan for, and forgive me now, I'm not that used to the dollar amounts now, but you buy a minivan for hundreds of thousands of dollars, right, or millions of dollars. Um, every day you have that minivan on the road, you want it to be full, right? Every trip you make with the minivan, you want the minivan to be full. Because that's how you're gonna make the most money out of it. And not only that, you want to run it as long as possible throughout the day, right? So running your minivan full for 3 hours during the day, right, and then leaving it idle, right, is money being wasted because you're probably paying interest on the loan, right? You're paying insurance on the vehicle, licensing, right? Then there's maintenance that you have to pay for, and so forth and so on. So you want to be able to utilize as much as possible what you pay for. And in this approach, right, a lot of your paid capacity or the capacity that you pay for becomes wasted. Now, once your capacity grows to that point where you're no longer being underutilized, you have another issue, right? Enough to forecast and spin up new resources and new hardware, right, to run your application as it grows. It could mean that you're going to lose business. Let's say you're running a supply chain application. If your servers can't meet the demand, it either means you have to slow down orders, right, take fewer orders, right. This might mean that you're now up to serving 2,000 users, right, or 2,000 customers. But the market demands that, or is indicating that there's a demand for or 2,500 customers that are demanding your products. No, you can't take on those additional 500 customers because you don't have the server capacity to process the orders and ship them and so forth. So you have to cut back on your business and lose out on growth in that regard. So there is what we call losing out on an opportunity, right? And it can cost you in the long term because if your business is not growing, then you're not making profit as much profits as you should, and you're losing money. Now, what the cloud does, right, is solve for that by providing elasticity. And what that means is that you have the capability to increase your resources or your capacity depending on the growth of your business or the growth of your application. And if you're not using that capacity, then the elasticity of the cloud gives you the option to reduce the amount of infrastructure that you provision for that. So on a typical day, you might need 10 CPUs, right, to run your application. You don't need to provision more than 10, maybe 12 CPU to give you a little headroom, right? Whereas in the older model, right, you would have had to provision for 20 CPUs because that's what you think you're gonna need 1 year or 2 years from now. And it's not that easy to change out and upgrade to newer hardware. So you see the blue line here, that's the old approach. So you have to keep buying new hardware or new capacity, right? And that capacity is fixed over time until you buy additional hardware. All right, then yeah, you increase that capacity. So following the blue line here, then it becomes a fixed amount again for the next 2-3 years, right? And until you increase that, then you might have some problems. So what we're seeing here at the red triangle is where, again, demand catches up with your application, or with the capacity that you have, the limited capacity that you have, and you're gonna miss out on being able to serve additional customers to grow your business. With the cloud, so the yellow line is actually the virtualization of the cloud, and the red line is the actual demand for your business, right? And what your application need in order to support your business. So you can see here, as that demand grows, you can increase the amount of capacity that you have and decrease it to reduce costs. And this green line here is showing you where with the old approach, right, because you already bought all of this capacity here, right, it's really being wasted. Whereas you could have reduced your costs, right, and who knows by how much, save some money until another time when you need that capacity, right, you can increase it, right, along with the growth of your business. So that's what the cloud does. And with all of that, you're talking about paying for resources on demand or as you use it, versus all that capital expenditure upfront, right? Think about provisioning a new server. You have to buy the server, the networking, the storage. Then there's a data center space, the UPS, the power, the lighting, the air conditioning, and then there are all the people who have to support all of those things, right? Again, I guess there's a difference between Jamaican and Canadian money here, but you're thinking about probably, depending on the application, that is hundreds of thousands of dollars, maybe millions, right? Capitalize that or depreciate that over, say 3 to 4 years. It's a lot of money per month. Compare that with the cloud, for example, and this is just an example now. I'm not saying your application necessarily would only cost that much. But, for one, you're using Firebase, for example, right? The free tier, you're building apps with that, right? And, all of that is being supported by servers and storage and networking in the back end. If you had to do that on premise, right, then you'd have had to, be shelling out, a good amount of money for servers and somewhere to put it on networking and storage and so forth and so on. In Google Cloud, if you were to pay for compute, right, you can get compute for as little as less than a cent per vCPU per hour. All right, so that's 1 cent, less than 1 cent per virtual CPU per hour. And for if you're using Google Cloud Storage as a storage, for example, you can get that for as little as 2 cents per gigabyte per month, right? Starting with a standard tier, and that can be less if you go with the the slower tiers for archiving. So that's what the cloud that's what the cloud does, and that's what it solves for in terms of value, right? Reducing costs and providing you through elasticity, right? And giving you options in terms of how you deploy your services. So let's talk a little bit about infrastructure services, right? And what we're looking on here are the 5 main pillars of cloud computing, according to NIST. That's the National Institute of Standards and Technology. That's the United States National Institute of Standards and Technology, anyway, right? And what these 5 pillars are demanding is that, one, cloud computing, all right, if you think about your cloud services provider here, should provide an on-demand self-service. So you need compute, click, 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 you go online, you have compute, right? You go on Google Cloud, click, click, you need a bucket to store some files, right? Couple clicks, you have storage. You don't even have to tell it how much storage you need, right? You just create a bucket, and you start storing your files, and you automatically get billed for how much storage you use, You want compute, you click, click, click. I need 10 vCPUs, 10 virtual CPUs, right? With automation in the back end, Google Cloud goes about and give you a virtual machine with 10 CPU, 10 virtual CPUs, and some storage as well. The second pillar basically states that your cloud application or cloud service should be available anywhere and everywhere. So if you're running it in Canada, I should be able to access it from home, from work, from the USA, from Jamaica, right? As long as I can connect to the cloud network. No, there are some caveats to that, to be honest, because, and we're going to get into that when we talk about regions and data centers, because if I deploy an application in a region or data center here on Canada, the experience you get using that application in Jamaica might be slightly different from the experience here I get in Canada. And that's just because of our latency, network latency. We can solve for that in many ways, right? But for the most part, right, you have to take into consideration that, yeah, even though it's available on the network, it may not necessarily be the same experience wherever or however you access it. And then there's resource pooling. So this is how cloud providers now, for their purposes, provide economies of scale. So instead of buying one server, right, and making one server available for company XYZ, and then another server available for company ABC, right? They split up that server and say, hey, you know what, company ABC and XYZ, you can share the server, right? That reduces my cost, right? And the capacity that I save, right, will be capacity that I can provision to other customers and make some more money. And what that means is that I also have extra capacity for when I want to scale up, right? So this is where we get into the economies of scale of computing, right, by sharing and pooling resources. Sorry, just a minute there. Yeah, sorry about that. All right, so, and then we talk about rapid elasticity. So that's where we're talking about having the ability to scale up or scale down as needed. We might have 10 virtual CPUs provisioned on our compute virtual machine, and we need to run a batch job on that same machine. We can scale it up to 15 virtual CPUs. Once that batch job is done, I no longer need that extra virtual CPU. I don't want to pay for it. So I can rapidly and quickly and easily scale it back down to 10. Right. So that's what elasticity means. And that's a fourth pillar for cloud computing. And then measured service. So, with all of that elasticity, right, you're either paying extra, right, to the cloud vendor for being able to use that added capacity, right, or having that elasticity to scale, or you're paying less, right, when you scale down, and we charge you only for what you use. So if you're using less, right, it's a measured service, and we charge you only for what you use. If you're using more, then certainly we're gonna, based on how it's measured, we're gonna charge for more. Keep in mind that Google uses per second billing, right? So if you're using that extra 15 vCPUs for 11 hours, 58 minutes, and 58 seconds, for example, we're only going to charge you for 11 hours, 58 minutes, and 58 seconds. We're not going to charge you for 12 hours. And I can just, if you are interested, I just want to show you there. So here, I don't know if this is something you guys looked at already. So when I started at Oracle, so before I joined Google, I was working at Oracle, and my manager at the time was well into the cloud. He, was speaking, going around, giving speeches on cloud computing. And one of the first things he referred me to was this definition of cloud computing. And yeah, so if this is a good reference for what it is, right? You can always go back to this. So here, right, are the 5 pillars that I just described. um, and then yeah, I'm going to talk about software as a service as well, platform as a service, and then the deployment model. So you have private cloud, community cloud. So private cloud is something that a company would run internally to themselves for their own purpose. Community cloud, maybe a group of companies, usually like a group of hospitals, for example, might do something like that, where they have a community cloud, right, for all the hospitals, or a group of schools. And then public cloud, of course, which is like Google and AWS and Azure. And then you have hybrid cloud, which is a combination of any of the above. So it could be a combination of private cloud, public cloud, community, and public cloud. All right, thank you for that, Joel. So yeah, so the next slide was gonna be about the different types of services. Now, these are only the services that are defined under NIST, right? In everyday conversations, you might hear about other as a service, right? Type of services. So you might have network as a service, for example, or AI as a service, or database as a service. That's a common one because I work with databases. You hear database as a service very often, DBAS. I think I said storage as a service already. So yeah, these are just the main pillars, right? And the basic ones that are defined under NIST. And you have to have at least these three, right? In defining or providing a cloud service. And here you see how the 4 of them compare, or the 3 of them compare with on-premise. So on the left, on-premise, right, you see that you have to take care of everything. As a company or as a user, or your on-premise data center or infrastructure, right, requires your involvement in the everyday management and operation of all the different stacks. So from application to networking, right, you as the owner of that on-premise data center, everything. And then we go into IaaS, which takes care of some of the lower components. So infrastructure as a service now, as it suggests, takes care of the infrastructure, so the virtualization, the server, storage, networking. Whereas you as the customer or a user takes care of all the layers on top of that. I'm not quite sure. There's a little bit of a gray area there, to be honest, as far as OS is concerned, because like Google Cloud, for example, when you spin up a VM, we patch the operating system for you, right? So we make sure we take care of patching the operating system. But to configure the operating system, or to add a new disk, or create a new device, or to install new libraries on that operating system, you as a customer, right, would have to do that. So OS is a little bit of a gray area there where IaaS is concerned. And then, yeah, you take care of your own middleware software, your runtime for your applications, your data, and of course the application code. PaaS now. Now, one thing to keep in mind, right, is that as you go from left to right, the cost is going to go up, right? Sorry, the cost is going to go down in terms of, what, if you think about your total cost of ownership, right? When you start with on-premise, right, it's going to cost you a lot, right? Because you're managing and paying for everything upfront. With IaaS, it's gonna cost you less because now the infrastructure is taken care of for you, and you only pay for what you use. With PaaS, you pay even less, right, in terms of a total cost of ownership, right? Because now we're taking care of the runtime, the middleware, and the operating system as well. And the only thing that you have to take care of is the data and the applications. And the reason why I use the term total cost of ownership here, right, is when you factor in things like the time it takes, right, to do certain things like, patch the operating system, for example, or upgrade the operating system or the middleware. There isn't a dollar value attached to that, but from an accounting perspective, right, there is a cost because if you whichever company you're working for, right, the people in finance and accounting, there are dollar value per hour to what it costs each person to maintain these things, based on what they pay you, of course. And then software as a service, right? Again, you pay, and then with comparing PaaS and SaaS here, for example, no, you don't even need to write any code, right? So development time is, I guess, zero. Um, some of these software as a service offerings do require some configuration before you can get going. So that kind of, even though it's a very small percentage in terms of the overall cost or time spent, you could, compare it to the amount of coding time that would go into developing your applications and deploying your own applications. But again, that configuration time, our cost is going to be significantly lower compared to what you would have to do in a PaaS environment. All right. So any questions there? I'll take a little pause before moving on. An example of software as a service is Salesforce, right? CRM. Salesforce runs the application in their own cloud. And then the only thing that you have to do is log into it. You can also consider Microsoft Office 360, 365 as software as a service, because you don't have to worry about the applications or the data underneath. You just log in and use it. Same with Adobe, software as a service. Yep. Not quite sure why I'm thinking so much Microsoft today, but yeah, Google Workspace, that's correct. Yeah, the PaaS would be like database as a service, so that would be like Google Cloud. Sorry, Google Cloud SQL, so Cloud SQL. Cloud Spanner would be considered, PaaS, right? App Engine, right? So Google Cloud App Engine and Cloud Functions, those would be considered PaaS, right? They aren't applications in themselves, but they enable you to run your applications without you having to worry about the underlying operating system, middleware, and so forth. And then examples of IaaS, of course, is storage, compute, and yeah, there are some networking resources as well, because in Google Cloud, you can actually provision routers, yeah, and proxies and so forth. Okay. Popular cloud providers. So who are the popular cloud providers? These are they. So Google Cloud, of course, AWS, Microsoft Azure. So AWS has a lion's share of the market today, right? Primarily because they kind of started pushing this whole thing, before most other cloud vendors. And what had happened is AWS, Amazon Web Services, Amazon realized, before they started this, that they needed a lot of capacity. One, not only to be able to handle unpredictable growth and workload when it comes to like Christmas and Black Friday and so forth. Um, Depending on the year and the products that come out and all different variables, right? It was very, difficult to predict how much capacity they were going to need around that time of year. So Black Friday into Christmas, right? Demand peaks, right? And then, yeah, they also have Prime Days as well. So they realized that they need to have a huge amount of spare capacity, but that costs a lot of money. The other issue they were facing at the time was there was a huge increase in the amount of um, DDoD attacks, so distributed denial of service, DDoS, sorry, distributed denial of service attacks. Essentially, what that is when hackers, right, or um, malicious actors, right, take over tens or hundreds of computers across the internet and then send messages to your front end. So they might send messages to Amazon, right, to log in, or even just to bring up the web page, right, and eventually having all of those machines accessing the same website and the same services, multiple times per second. If you don't have the capacity to handle that, eventually the website will go down. So that was one of the reasons they wanted to make sure that they have an excess amount of capacity as well, right? So even with a DDoS attack, right, they could withstand it. Um, Again, that costs a lot. So then they decide, hey, you know what? In order to make back some of that money, right, maybe we can build a service, a cloud service, whereby we can sell some of that extra capacity to other companies or users, right? That we can get back some of our money, right? And make a business out of it as well. They have controls in place whereby if they themselves needed that capacity, right, it wouldn't be an issue, right? Like they have certain type of compute instances, like some are on demand, some are, you know, some are provisioned in such a way that if you're not using it, right, you pay less, right, but then AWS can take that server or VM and put it in a pool. And this is how they really got started, right, in order to meet those business needs, and that grew over time. Not that Google and Microsoft weren't even thinking about that at the time. Google was actually busy building out the infrastructure that Google Cloud runs on today. So while Google was busy building out infrastructure and technology, open source, so Hadoop and Kubernetes and so forth, AWS already was out the gate, right, building up their and marketing their cloud services. So yeah, so they started marketing it and exposing it to the public, right? But because Google spent more time on the back end, on the infrastructure, right, and the technology before starting to make a lot of noise about their cloud, um, Google is now in a position where they have the better infrastructure, right, and better technology compared to the other major providers. And Microsoft, their thing is there are a lot of when they started, they had a lot of customers who they had already had a large share of customers running Microsoft products. So when you think about Windows, Active Directory, SQL Server, Access, Office, .NET, right? That's a big thing, right? So a lot of companies were already using those, and they just saw Microsoft Azure as a natural fit. Not only that, because they're Microsoft customers, they're seeing the Microsoft sales folks, right? And they, managed to make deals with them to move over to Azure. So that's kind of their thing, right? The .NET customers and the Microsoft Office customers and active, people who need Active Directory and so forth. That said, a lot of that you can do on Google Cloud as well, right? It's just not, where most of our focus is. And if you take a look, and kind of compare the types of products and services that these vendors provide, right, you'll see that a lot of them are similar. They're not the same now, but they're similar, right? So at the IaaS tier, right, for AWS, they have Elastic Compute or EC2. Azure have virtual machines, Google Cloud Compute Engine, and so forth and so on. And then for containers, they have EC2 container service. They also have Kubernetes, which Google developed and then open source. We have Kubernetes Engine and Azure. And you'll find the same for a lot of other services that aren't mentioned here. So they all have AI and ML services as well. They all have, comparable database services. Again, some of them are similar in a lot of ways, but they're not the same, right? They all have their own differences and, features that makes one, especially the Google Cloud services, better. So how is Google Cloud different? Now, when you think about all the services that Google Cloud provides, right, and the fact that, all of these services that we're looking at here have over 1 billion users, right? This is one of the things that differentiates us. And how this differentiates us is this: all the technology and the infrastructure that goes out in building these services and supporting these services is the exact same type of infrastructure, not the same infrastructure now, but the same technology, right? And learnings that goes into building these products that goes into Google Cloud. So the same technology that you interact with when you do a Google search or use Google Maps. I know Google Maps not a thing in Jamaica because I've used it and it's not the same. But yeah, let's say Gmail and Google search and Chrome and Android and so forth, right? It's the same technology in the backend, the same databases, Bigtable, for example, Cloud Spanner, Kubernetes containers, all the same that's in Google Cloud, right? So suffice it to say, if we can build these incredible products to support over 1 billion users, imagine what you can do, right? With Google, the same technology in Google Cloud. It may not be 1 billion users, but if we can do it for 1 billion users, certainly we can do it for 100 million or 10 million or 3 million, whatever the case might be. Yeah, I use Google. I was in Jamaica in June, man, and I tried using Google Maps, and I'm not even exaggerating when I said it took me in circles a couple of times. There was one time, I was up in Stony Hill and trying to find somewhere, and one guy just said, or use Google Maps, man, that'll make you lost. All right, cool. So the other thing with these products is that they all use machine learning, right? So you think about photos, right? And when you do a photo search, for example, that's AI and machine learning in the back end. Google search, same thing with speech recognition and even the search ranking itself. Gmail, Smart Reply, all of that AI and ML, right, technology is available in Google Cloud for you to use. And that's why a lot of customers go to Google Cloud for AI and ML, right? Because they like the experience that they get, and they like building products with Google's AI and ML products, right? Because they're proven and scalable. The other thing that makes Google Cloud different is the network. So it's not just one data center or two data centers, right, that makes up Google Cloud, right? We have data centers right across the globe, right across the world. So you're thinking about North America, South America, Europe, Asia, Africa. We have data centers all over, and those data centers are all connected by our own network. So Google's own network connect all of those data centers. No, it's not practical to have data center in every single geographical location. So where we don't have data centers, we have points of presence. So those are the little blue dots, right, or POPs. And what those are basically jumping on and jumping off points for Google Cloud Network. These might be, like a colo or a third party network center that connects their network to Google Cloud to provide access directly to Google Cloud, which means private access and security and performance. So basically, we have our own network. When you deploy something like Google Cloud multi-region storage buckets, for example, and it has to replicate between two regions in, say, Europe or in America, that traffic or that data, so the data for your files is being replicated on Google's network. It's not going over the internet, right, where can get exposed, and people can probably do things on other networks to get access to it. It's only on Google's network, so it's secure, and we guarantee the performance as well. So we take this. The other thing that we do, right, is connect these networks using our own submarine cables, right? So we actually run cables across the oceans and the seas to connect our network. So these are our own network cables running under the ocean. And we can probably do another session on this, or I can share a YouTube or link with you that shows, because of how these fiber networks are, there are so many of these fiber networks running under the sea, and where they run, we can actually sense whenever a network has occurred. I remember when Jamaica had an earthquake. I think it was 2017 or 2018. Google was actually able to detect, based on signals on these cables, right, that an earthquake, where the center of that earthquake was, and that an earthquake had occurred without even, experiencing it or hearing it on the news, that it had occurred. And we make sure that the cables are actually even shark resistant. I'm not quite sure why sharks are trying to bite these cables, to be honest, but just in case, right, they're tough enough and hardy enough that if they try or do, they won't be able to damage the cables. So this just shows you how your network traffic would flow, right, on a typical cloud provider network versus on Google Cloud. So on your typical cloud provider, your network traffic leaves the cloud provider data center and then jumps onto the internet. And once it's on the internet, you have no idea whose network it's going to be running on. Right, so it's gonna be, making hops across the internet on different networks until eventually it gets to your user or maybe their other data center. With Google Cloud, that's not the case, right? Your network traffic only traverses Google's network, so that means it's secure, right, and your performance is guaranteed. All right. Any questions before we go into the other sections? All right. So in terms of the network and infrastructure, so we have regions and zones, and we even have multi-region. So a multi-region is basically a continent. So Europe is a multi-region, and the US is a multi-region. And when you go to provision certain services like BigQuery, for example, or cloud storage, it asks you if you want to do this multi-region. And what that means is, if you select the multi-region option, it will automatically replicate your data within, that area, right? So Europe or the US. So you don't have to worry about redundancy or networking. Automatically, you have multiple copies of your data in different locations. Then we have regions, and an example here is Europe West 2 in the UK. Our regions are made up of 3 zones. So in this case, you have Europe West 2A, Europe West 2B, Europe West 2C. This is for redundancy. Each zone is actually a separate data center, right? So these are 3 data centers, separate and distinct data centers that are totally redundant, but connected in a single geographical location. And then you have, the only thing I haven't mentioned here is the edge node. So these Google Global caches, right, are basically, data centers or edge points where we cache things like YouTube, for example. So to ensure that you get the best performance or best experience with YouTube, if certain areas or cities are near to a Google data center, right, we set up a edge node, right, and cache data there, right, so that they get the same rich, low latency, quick, fast response times as if they were close to the data center. All right. So gonna go through some of the services that we have in Google Cloud. This isn't actually a service onto its own, but it's more or less I guess you could say a feature. So Cloud IAM, so Identity and Access Management. This gives you the ability to control who has access to what in Google Cloud. So if you have a project, and I'm gonna get into projects later on, but your project is basically where you have all your resources, your computer storage, your applications, and so forth. And you have resources, provisioned within that project. So again, compute, storage, applications. You can decide with Cloud IAM who gets access to that. So once a person have an ID in Google Cloud, right, or even in your project, they don't automatically get access to everything. You go use Cloud IAM to determine whether they have access or not and how much access. And by that we mean least privileged. So you have the ability to give them only the privilege that they need, no more. So this is what an IAM policy would look like. So you determine who, so that would be the person's ID, can do what. Let's say BigQuery admin. That would actually be the name of the privilege, and then on which resource, let's say BigQuery, and that's it. That's what an IAM policy is. This is just another look at that. So identity, so that it can be a user account, a group of users. So you can, bring users together into a group. And you can also have a service account, which isn't assigned to a user. So it doesn't have a password for you to log into it. These tend to use keys for access. And a service account is basically what you'd use to like run an application or a service, but someone doesn't use it. And you can even give those service accounts their own access to different resources as well using IAM rules. So I'm going to skip this. So let's talk about compute engine. Keep in mind, compute engine is just one form of compute that we have. A compute engine instance is a virtual machine. Then you have Google Kubernetes engine, which is, again, compute machines, but with containers running on them. And Kubernetes allow you to orchestrate and manage all of those machines and all the containers on those machines. There's App Engine, which is serverless. App Engine basically gives you the ability to just submit your code for execution. You don't have to worry about the operating system or logging into it or how many CPUs it have or how much memory, right? You just submit your code running and you pay for how much time and how much resources your code uses. And then there is a cloud function as well, which gives you the ability to create functions which can be triggered based on events or HTTP. However, again, this is serverless, so you're not worrying about the underlying compute, but it's based on compute under the covers, except you as a user or consumer doesn't see those compute resources. And the same with Cloud Run, which is basically the newer version of App Engine. App Engine isn't going anywhere, but Cloud Run is based on containers. So Cloud Run allows you to run applications as containers easily on compute services in the backend. So again, compute engine is virtual machines, and you have the ability to either provision high CPUs or high memory. You can provision standard or shared core machine types. So what then? So standard is basically an Intel CPU or Intel Core has 2 threads in Google Cloud and most cloud providers. Each of those threads is considered a vCPU. So each core is basically split in 2. A standard machine would be assigned as per the vCPU, and those virtual CPUs can come from anywhere and don't necessarily come from one machine, or you can use a shared core machine type. The difference there is that with the shared core machine type, it means 2 vCPUs would come from the same core, and you tend to get better performance with that type of configuration. Persistent disk is assigned to your compute engine for storage, and persistent disk is basically block storage or your file system. You can configure that as you need in terms of the size and type of file system you want it to be, depending on whether it's Windows or Linux. You can configure the type of Linux file system as well, or maybe just a raw device or whatever you need it to be. You have standard disk, so that's just standard hard disk, solid state disk, and local SSD. The local SSD is basically attached to the machine. You have the ability to take snapshots. So let's say your machine running, and then you're going to apply an application update, or you're going to change some of the operating system parameters, or some other kind of change, but you want to take a backup of your VM. You can take a snapshot of that and store it in Google Cloud. And if something goes wrong with your update, or for whatever reason, maybe you're just doing a test and then you want to go back to the original version before you take the snapshot, then you can restore that snapshot, or you can use that snapshot to spin up another machine with the exact same configuration. You can also resize this with no downtime. That's one of the nice features about it. And then you have instance metadata and startup scripts. So basically, you can store data from your application as part of the metadata, so that within that compute instance, it can grab information about the application that it might need to run, say, batch jobs or something else. And then you can also have startup scripts that say, hey, whenever this VM machine start up, I want to start up the applications as well, or I want to back up the disk or something like that. And then you have the ability to scale up or scale out with compute engine. So you can increase the number of vCPUs, or you can increase the number of CPU machines by scaling out. Oh, one thing I'm going to point out here is the live migration, which is unique to Google. So live migration means that your VM can move from one physical machine in the Google Cloud Data Center to another physical machine without your application being shut down or without you even knowing it. So that's one of the beauties about Google Cloud Compute Engine, right? So that gives us the ability to say, hey, this machine is going to go bad. I'm going to move your VM over to another physical machine, right? And I'm going to take that, machine that's going bad out of commission, right? And you wouldn't even know it. It also means that they can patch the firmware, or if there are bugs or security holes, they can address those, without bringing down your applications. Yeah. So Cloud Functions now is more on the application side of things. It's event driven and it's serverless. And basically just gives you a simple interface, a few mouse clicks and options to choose. You can submit some code and have that code run or executed automatically. You don't have to worry about the server portion of it, how many CPUs, memory, that sort of thing. Um, and then have that code executed whenever an event occurs. So some of the events, right? So the trigger can be an event or HTTP, URL, right? So, it's basically like an API call. And these, yes, exactly. That's how you'd use it with Firebase, for example, or Firestore, like a backend server. Yeah, so this shows some of the services that will trigger it. So cloud storage, like if you put something, a new file comes into a cloud storage bucket, you can trigger a function that then does something that acts on, say, BigQuery or AIML or Cloud Spanner, Dialogflow, Dataflow, something else. And you see Firebase here as one of the potential sources for those events. Cloud Scheduler, of course, you could schedule like an HTTP or make a call right to your HTTP endpoint, right, to trigger your function. So in terms of storage, we have three types of storage that you might be interested in. Cloud storage, which is block storage, allows you to store anything basically, but you don't have to. It's not block storage; it's blob storage. So BLOB. What this means is that you can store any type of file right on it, but it's not the type of storage that you can use for, say, a database, right? You can store things like MP3 files or video files or PDFs, right? Basically anything on this type of storage, right? You only pay for what you use, right? There's no size allocation when you provision it. Then there's persistent disk, which is block storage, which is your traditional type of file system storage, which you would assign normally to a VM. And this kind of storage, you can use for like a database. And then there's Firestore, which is network attached storage. So network attached storage, it's block storage, but it's available on the network, and you cannot assign it to multiple VMs, for example. For things like maybe backup and restore, or even on premise, right, to access files that may be created in the cloud that you want to access on premise. I'm gonna skip that. Skip that. When you provision cloud storage, you have three different classes. So standard tier, that's basically your default. You can do that in multi-region where it's replicated automatically for you. And by the way, that's only available in the US and Europe. So if you're deploying applications in the US, you can take advantage of it. Then there's nearline storage. So if you want to pay less and you don't mind a little, less performance, you can go for nearline storage. And then there's cold line and archive. So as you go to the right, the storage costs less and less. So we're talking about like less than pennies now. But it means that you don't access the data as often. And when you do, it probably takes a longer time for you to actually retrieve the data. So this just gives you an idea of what multi-region means in terms of cloud storage. So multi-region or dual region. So some areas, so like in Asia, for example, and Canada have only 2 regions. So that's where dual region comes in. And you specify which 2 regions. And then multi-region, you don't specify. The Google Cloud in the backend decides which 2 region it would use to replicate, or it may even use more than 2. So if one region goes down that is replicating to, it might select a different region. So it's all automatic, whereas dual region, it's kind of fixed. And then regional, you get lower because there's no replication with regional. It's faster. So, to get better performance, you'd go with regional, but then you compromise on the redundancy. This is actually available on the internet. So it's a really cool diagram that explains the difference between the two. So if you Google which storage should I use, you'll actually find it. And yeah, it shows you how to decide which one you'll need. So, cloud storage, for example, good for binary or object data, blobs, unstructured data. This is good block store for VMs. It gives even better performance than cloud storage. So if you're looking for performance, this is a guide to go with. And then Firestore, good for shared file storage on and unstructured data. All right. So let me take a stab at giving you, at this point, before I go any further, a quick walkthrough of some of those services. And yeah, feel free to ask any questions you might have at this point while I get in here. So this is the Google Cloud Console, and keep in mind some of the things here might look a little bit different from what you see on the outside, because this is, my account and my version internal here to Google. So full disclosure, some things, could be here that you don't see yet available on the external one. Also, some things might not work the same or be a little bit different because they put some restrictions on how we use it. One for cost and 2 for security. So one of the things I'll point out here is that you have a menu down the side here where you can look for the products that you need, right? So this is one way to find which product you need. You can pin products here, right, that you access frequently. And if you do more products and you scroll through, you'll see all the different products. So you have compute here, compute engine so far, and so forth. Serverless, Cloud Run, Cloud Functions, App Engine, Firestore, which we just talked about, cloud storage, then databases, and so forth. But you can also just search for whatever you need. So if I want to look for IAM, for example, IAM and admin, right, there it is, right? And that's rather than going, the menu is getting longer and longer. So that's an easy way to get at it. And so with IAM admin here, right, we spoke about IAM earlier. You'll see that Winston Douglas is the owner for this project. That's my name there. And yeah, and that's what, an IAM role assignment would look like. So I have owner here. I can add other roles to myself, but there's really no need to because I already have full access to this. Now, these are service accounts, and I can add other users here. So for example, if I say grant access, new principal, I can add my friend Larkland, for example, Larkland Morley, assign roles, select a role, and I can go through and maybe I only want to give him access to BigQuery, right? I can say BigQuery admin, right, and give him access to that. Right, and save. I really don't want to, so I'm not going to save it. But yeah, if I wanted to give Larkland access to BigQuery admin within my project, that's how I would do it in IAM. So that's basically where you'll be doing most of your work with IAM. You have different views, view by roles to see, which roles have been assigned out and who have access to them, right? So this is just another view for it. We spoke about compute, right? So compute engine. So when you come into the compute engine console here, right away you can see, what's this? service agent. I don't know.
Yeah,
right away, I have 3 instances already created, right? I can SSH into those instances. Oh, you probably can't see that. Let's see if I can add it to the screen. Yeah, it opened in another window, so you're not able to see. Let me try to see. Anyway, in a nutshell, it opens a SSH window, which I can, which I can then go and type Linux or Unix commands. I can click on these instances to see all the details. Right, so here it shows in the name, description, type, whether it's running or not, creation time, machine information, E7 medium. So machines are assigned in terms of type. So, and the type is typically based on CPU, right, or memory. So this is E2 medium, right? It's based on Intel Broadwell, and it has, the amount of CPU and memory is considered medium in terms of the range of possibilities that Google Cloud offers. No GPUs assigned. We're not allowed to assign GPUs in our in these accounts here in Google. You can see the networking setup, the interfaces, storage assigned, and so forth. And most of the consoles are very similar to this, right? Here you can see disks that are assigned to my instances. So instance 1, balanced persistent disk, 10 gigabyte. The zones that they're assigned in, snapshot schedule, no snapshots, right? If I had any snapshots, I would see it here. My users is, what am I looking for here? Health checks. Right, health checks. It does automatically does health checks, in case there are any issues with your VMs, it will show you here. So that's just a quick run through of, what, the Compute Engine console looks like. What else do we cover? Storage. No, not that. Cloud storage, this one. Yeah. It's interesting. Oh, I was wondering where this came from. I think I did that just recently, just this morning. So I created a bucket, in Google Cloud Storage, and in that bucket I uploaded a couple of files. What you'll see here is public access, not public. If I wanted to make this accessible to the public, so here's the thing. Normally in Google Cloud, you could give public access. It's not recommended for the most part, only if you have to, but we do have that capability and that feature does exist. However, with my assignment here in Google, they totally bar us from doing that. So even if I wanted to give you access to these files, I wouldn't be able to because of our organizational policies. And that's something that you can set up in Google Cloud as well, right? When you get a Google Cloud, when you subscribe to Google Cloud, right, it's assigned at the organization level, and that whoever has control of the organization, right, can create policies to determine what can be done within that Google Cloud subscription and what can't be done. So if they want to disallow public buckets, for example, or exposing files to the public, they can create a policy for that. But in terms of uploading files, right, it's very easy. You can just click on the upload, select a file from your operating system and upload it. And also you have a command line, right? So if I click here, I have the ability to say GC util, for example. Okay, so command line, Google Cloud, and then which is for Google Cloud Storage, right? So gsutil, these are some of the commands that you can execute. So bucket policy only, cat compose config course. So yeah, so you have command line for a lot of the things that you can use here. gsutil gives you the ability to say, for example, copy a file from one place to another into maybe into your cloud bucket, or from your cloud bucket back to a server or operating system. Any question, guys? I'm gonna move on here, if that's okay. All right, so let me switch back to here. Okay. Okay, so it sounds to me that you guys are already familiar with Firestore and Firebase. Firestore is a serverless document database. So what that means is if you have JSON documents that you need to store, and you need to do that, um, in a in a way that's reliable, right, and consistent, right, then Firestore allows you to do that. And by consistency, we're talking about ACID, so atomicity in terms of ACID transactions, consistency, durability, right. It basically means that when you you save a transaction, right, there's no chance of it being inconsistent from point to point or between one user or another, right? The same thing that one user sees in terms of that transaction when you do say an insert update, for example, is the same thing that every user would see or nothing at all. Because Firestore is built on top of Cloud Spanner and Cloud Bigtable, it gives you 5 nines availability. That basically means that it would only be down for 5 minutes, the maximum for any 1 month, or even less. So that's for the entire year, actually. So it would be even less for a month. And you pay for only what you consume. So you're not even spinning up servers or anything, based on the calls, right? The number of reads and writes that you do to Firestore, you pay for those. And yeah, and if you don't use any, then you don't pay for anything in Firestore. Firestore and Firebase is actually one of the most popular Google Cloud services, right? And I think one of the reasons for that is not only is Firebase a really great product, but there's a very generous free tier, right, where you can do a lot of things for very little or for free. So it's very secure. It has a secure backend service. Cloud Functions is a part of that. Real-time sync and offline caching. What that means is that with just a couple lines of code, if you write a mobile application and your mobile application goes offline for whatever reason, let's say you're on a flight, and your app, somebody's entering something in the application or had entered something in the application before it went offline. Once it comes back online and communicates back with Firestore, it will automatically sync, and you don't even need to write any code for that. Sync both ways, actually. So from the mobile device back to Firestore, and from Firestore up back to the mobile device. And it integrates with a lot of Google Cloud products. So talking about like Google, Cloud Functions, Cloud Run, right? You definitely can take advantage of the SDK and the events, right, to integrate with the other backend services. And some numbers there to the side that kind of show you how popular it is. So on the left here is all the backend service that it integrates with. Data flow, if you're creating data pipelines and doing ETL, cloud functions, cloud run, if you need to run a service within a container, App Engine to run some code again, BigQuery for analytics, Kubernetes engine, if you're running a cluster with a lot of containers. All of these services you can integrate in the backend with Firestore. So if you're writing your Firebase application, storing data in Firestore, and then you need to scale out and do some further backend processes. I think this is what Joel was saying, right? You can take advantage and do that using Cloud Functions or any of these other services that you see on the left. Flutter is also a very popular framework that's being used with Firebase, right? So, I don't know if you're looking on that today, but, that's something that you might also want to take a look at. Yeah, and this just shows you some of the other, languages and SDKs to integrate with it. In terms of administration, you can use Terraform for deployment, Google Cloud CLI, which I was just showing you in the console there, and there's also a Firebase CLI. And you have API interface. All of Google's products, right, have an API interface that you can access using either REST services or gRPC. So that's Google Remote Procedure Call, right, which is basically an advanced version of REST where it compresses the data and provide you with, secure, efficient communications, more so than what you'd get with REST. And if it's okay, I'm going to skip this for now. So this just shows you how with real-time data sync for Firestore with just 2 lines of code, right? You can set this up and your devices will automatically sync with Firestore. It doesn't matter if they're online or offline, right? Where, if they go offline, when they come back online, they'll automatically sync with Firestore. If there are updates in Firestore that isn't in the app, then it pushes them out, or vice versa. So as I mentioned before, right, all of our products are available or accessible through APIs. You in the console, you actually have to enable some of these before you can actually use the service itself. So take BigQuery, for example. Before you can use BigQuery, you actually have to enable the service before you use it. So this is a key part of Google Cloud Platform, right? And it's actually a means of securing and accessing and controlling access to applications. Whether it's computing, networking, or storage, or machine learning, right? You can use APIs to add these services to your applications as you need to. And then here you see where they're exposed as a network service. So this is just the endpoint for the compute service. Yeah, and you can see here it's just standard HTTPS : your service name there .googleapis.com, and then the documentation will show you whatever functions and calls you can make after that. So you have interfaces for JSON, HTTP, and gRPC. So Google Remote Procedure Calls, client libraries, and all the popular programming languages. Come on. Yeah, all the popular programming languages, right? So if you're programming in Node.js, right, that seems to be a very popular one now. You can access these client libraries and APIs through that as well. Python also, yeah, but Node.js seems to be the new flavor of the day. Um, and also the Firebase SDK, Google Cloud CLI, so G. Oh, what's happening here? New site. Yeah, so yeah, Google Cloud CLI. So again, all the services similar to this, right? Have access through the CLI interface. Yes. Yeah, through the CLI interface, similar to this. So BigQuery would be something like BQ something 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 on the command line. Um, Things like our network, for example, might be G-Cloud network, something, something, something. Um, but yeah, it's, if you look at the documentation here, oh, actually, this is not the documentation. This is the console. Um, and this shows you where you would go to manage your APIs. So take BigQuery. BigQuery API, BigQuery API. All right, here is this one is already enabled, so it says API enabled, so I can use BigQuery, and I can manage it, right? So all the services have this, right? And you can enable and disable them depending on whether you want users accessing them, right? It's mainly a security thing and control, right? So to be absolutely sure that even if someone hack into your console, right, or hack into your network, right? If you're not using BigQuery, you just disable it. So AI and ML is used across all our products. So again, search, Android, Google Play Store, Chrome, Maps, Drive, YouTube, Gmail, Google Translate, Google Photos. All of these products have AI and ML built into them, and this is where we get the technology and the learnings and include them as part of the services that we provide in the cloud. Here you can see Google Translate in action. So you have the Google Translate app on your phone. You hold it up to a sign, right? It will translate that sign into another language for you. And I still think somebody needs to do this for Jamaican language. Google Photos. You probably have Google Photos on your phone. You go into Google Photos, you search for dogs, or you search for iceberg, or you search for mountains, or roses. It'll bring up the photos that have those search terms within them, and that's all based on our AI ML technology. Gmail Smart Reply. We actually find that 12% of all Gmail responses are based on Gmail Smart Reply. Um, so that's interesting, right? A lot of people are using it. Maybe they're busy and they need to respond quickly, so they just go with the Smart Reply. But those smart replies are built on AI and ML, right? And again, we also make that technology available in Google Cloud. So one of the technologies that we make available to customers in Google Cloud is AutoML. And what AutoML is, right, is an easy way for you to build machine learning and AI models. You provide a data set to it, right? You say, hey, here is some data about real estate. Here's some real estate data, for example, about houses sold in Jamaica, where they were sold, how much they were sold for, blah, blah, blah. Run some AI on it, and what I want to predict is the price for a particular house, how much it might or should or is going to sell for in, say, Negril, right? And it will use that data, right, to build a model and then generate a REST API. So then when you make a call now using that REST API, you can provide certain parameters, maybe the location in Jamaica, maybe the size of the house, maybe the number of bedrooms, so forth and so on. And it will give you a prediction back to say, hey, this house should sell for XYZ, or it's more likely gonna sell for XYZ, something to that effect. BigQuery machine learning, BQML, is another cool feature, which I like in Google Cloud. So, and there's a sandbox available for BigQuery, by the way. So if you're looking for something that isn't gonna cost you anything, you can't do a lot in there. You can't utilize all the features in BigQuery. But if you go here, right, in case you weren't aware, there's a BigQuery sandbox available. So just search for BigQuery sandbox, and you'll find that you can spin up BigQuery pretty easily and start on some of our public data sets, and even, public data sets really, without paying anything. There's also the Google Cloud free tier as well. But yeah, with just two steps or two statements, you can create a machine learning model using SQL statements, right? And then use those SQL statements with the same data in BigQuery without getting out of BigQuery, right? You can do predictions on it. So that's pretty cool. This shows AutoML Vision. So similar to AutoML, right? AutoML Vision allows you to submit tagged images. So you give it a number of images of hats, for example, but you tell it that it's a hat, right? And what AutoML Vision does basically study those images, right, and come up with a model of what a hat is, right? And so the next time you submit an image of a hat, based on the data that you provided originally, it will say this is a hat. So in the case of Jamaica, for example, you might want to train this using, say, the hat that a dreadlocks wear, right? Or like one of those hats that Capleton wear, for example, and make it even smarter so that the next time you show it one of those hats, right, it knows it's a hat. I don't even know if those are called hats, but just as an example. And then you have AutoML Vision, which you can train to recognize objects. So again, right on the right-hand side, that's a moving car. Maybe you can train it to recognize, a public transportation vehicle in Jamaica, right? Pick up where they are in traffic in halfway tree, for example, something like that. And they can be trained and to recognize like action, for example. This year is like somebody celebrating a goal, or to hone in on a particular area in a picture, right? So if you want to search for and do classification of, say, a stadium, right, it can figure out where exactly in that picture the stadium is, right, and do predictions based on that. The left hand box, right? Basically, what this is saying is that you give it an entire video. So, a whole Ellen DeGeneres series, for example, and then it will be able to, next time you give it an Ellen series or video, it will be able to tell you, hey, this is Ellen DeGeneres' show, right? Or this is a daytime talk show, something like that. And then we have visual inspection AI. If you guys don't mind, I can go over another 10 minutes if that's okay.
Yes, that's fine.
Okay, cool. something they are using it more and more, right? To in sports. One thing that's popular here in North America is contact center AI. And what this does is, when you call a customer support center, right, and they say, this call might be recorded, they actually record them. But for years, nobody actually listened to them, or probably just listened to a few of them. What this service does, right, it gives those contact centers or customer service centers now the ability to upload all of those recordings, right? And Google Contact Center AI can scan the recordings by sound only. So just listen to the interaction, the voice interaction, and can tell, hey, in general, your customers aren't happy. Calls are being terminated quickly. Customers are using a lot of curse words, so, that's something you might want to look into. So, sentiment analysis is what they call it, right? Is one thing. Or, it can, determine whether, calls are lasting too long to solve a problem, depending on what it might be, that sort of thing. Or if customers are using a certain word very often when they call, maybe you're a bank and you have a call center, and you notice every time a customer called, they mention the word interest rate, interest rate, interest rate. Maybe that might be an indication, that you need to come up with some interest rate savings product, right, that might capture some of that audience. No, the latest thing in Google Cloud as far as AI is concerned, so if you're looking at AI, is Vertex AI. So what Vertex AI does, all of the services that I just mentioned, it tries to bring all of those together, right, and give you an interface where you can curate the data, do things like data labeling, feature engineer the data. So let's say the data is no good as a character. It may convert, numbers that are stored as characters into numbers, for example, that sort of thing. Help you decide on which features might make sense, help you run experiments, decide on the amount of training data. Because take the hat example, for example, maybe you're not getting good results because you only put in 3 pictures of hats, right? Vertex AI would say, hey, you know what, man, you're not really getting good results. You only put in, 3 pictures of hats. Based on, what you're doing, I think if you put in 10 pictures, right, you'll get better prediction, right? So that's the kind of thing that AutoML does. It brings all the services together into one place. And then you have did that. Okay, I was gonna do a little bit of data analytics, guys, but I'm gonna stop there. You're welcome, Joan. So let's see if I'm still logged in here. As far as AI is concerned, you go here, you do more products, you scroll down, and when you come to here you go. So Vertex AI, right? And you can go to the Vertex AI dashboard. All right, and right here, because I've never used Vertex AI, it's telling me I need to enable all the APIs. And it will show me the API link. So Vertex AI API, Cloud Storage API, Notebooks API, data flow, and on and on and on. Right, but here on the left-hand side, you can see where, it allows you to do many things, right, that you would normally do individually. So manage your data set, for example, right? So yeah, here it's saying, yeah, giving you the option to create a data set. Normally you do these separately, right, as separate distinct products that you have to say, okay, what's the first step of creating a data set? That's all included here in Vertex AI. And then once you do it, so I'm not an AI/ML expert, full disclosure, but suffice it to say, right, Vertex AI is where most customers go now, right, in order to do AI, build AI and ML models, which they then can integrate into their applications, because ultimately that's what you want to do. Yeah, it's cool that you can build an AI model that, predicts, like how much a house will go for in Jamaica, or what type of sugar cane I should use to build a certain batch of Appleton rum. But if you can't integrate that into your applications, then it's all for naught. So this gives you the ability to do all of that in one console. Um, what else is there? I think I'm gonna stop there now. Is there any questions or anything else you'd want me to, show in the console?
Could you briefly touch on like how we could get certified with Google
Ah,
Cloud?
yes, 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 absolutely, absolutely. Okay, so let me go back here. All right. So, one, right, in terms of getting started with Google Cloud, there's a free tier. Actually, this is not the free tier. This is just the getting started for free. So, cloud.google.com/free, right? And then it shows you all the free products that you get, right? Some of them you can do individually, right? But some of them you get if you sign up for the free tier. So here it tells you $300 in free credit. So just to let you know, what you do here is part of the process. You give your credit card, right, and you get $300 in credits. If you use up all of those credits, then it start charging your credit card. So you have to be really, really careful, right? But it's a really good way to just start exploring Google Cloud, right, and use some of the services that cost less. So like compute, for example, you can use a whole lot of compute without going over that $300, and even storage. But if you start, and even BigQuery has a free tier, so 1 terabyte queries per month. And but yeah, certain services like Bigtable, for example, or Cloud Spanner, those are gonna get expensive really quick. So 20 plus free credits, 300 using the BigQuery sandbox. Oh, I had it here. And then there's Flutter as well, which is really popular now. Google Cloud certification. So I got the Google Cloud data engineering certification first. Then I got Google Cloud Google Cloud solutions architect. And those two are the two most popular ones, right? If you click on this, so Google Cloud.com certification, view certification, certified directory. So here you'll see all the different ones. So cloud architect, that's a good one. Database engineer, if you're into databases, that's a good one. And then data engineer. Oh, I just don't have cloud in front of it. Yeah, data engineer. So this one I've done. This one I've done. I did this once, but just for fun. I wanted to learn a little bit about networking. I would start with this one unless you're a developer and you really just want to get into the developer aspects of it. Cloud developer is a good one. Machine learning, very tough to do. But if you're interested in machine learning, I would say go for it. But yeah, the most popular ones are cloud architect and data engineer. So that's certification. What if I should give you any hints and tips, right? Doing the practice exams that is on the Google website is very helpful. Coursera have a number of courses that helps you prepare for the exams. Those are very helpful as well. And also, So there is a website, Linux Academy, right? That have test questions that can help you prepare. That's very good. And also, so there's Linux Academy and A Cloud Guru, right, in terms of training. So A Cloud Guru have some certification training there as well, which can help. But to be honest with you, if you really, read the material and absorb it, right, just a practice test and the examination and doing some labs as well. So Google have labs on the documentation website that you can do, right? Depending on how good you are at studying and remembering things, that alone might be enough. But these websites as well, like Aclude Guru and Linux Academy, are also very helpful. Yeah, so Coursera, Linux Academy, Udemy have some good labs and training. A Cloud Guru, Quick Labs, right? So take a look at Quick Labs. Quick Labs isn't free, but just check it out and see. Maybe some of them doesn't cost a lot, and you might be able to get away with doing a couple of those Quick Labs. All right, I think that's it. Any questions on that? And I actually checked. I was talking to Sean about this. So you actually can sit these exams in Jamaica in person if you prefer that. I think the testing office is called Overseas Examinations, and apparently they're in Kingston and Montego Bay. But you can also do it online. So most of these exams you can now do online, right? So you sit at home. Um, yeah, to be honest, the whole setup procedures when you do it at home and the distraction, I personally prefer to go into the office and do it. So proctored, that's really my preference. Yeah, so that's it. Unless there are any questions, I'll be happy to answer them before we go. But yeah, that's all I have for now.
Okay, doesn't look like there's any questions.
Okay.
Okay.
Thank you. Thank you, Joel.
All right. So I want to say thank you very much, Mr. Douglas. That was a really great presentation. And we really appreciate you taking the time out to come and share with us. And I'm sure we all learned a lot today. And we'll definitely be using some of these services in our own projects. Right. So once again, thank you for coming. And thanks to all the students that came out today. And yeah, this is the end of our meeting. Wish you
All right.
guys happy day.
Yeah. Thank you very much, Sean. It was a pleasure and, really nice to spend this time with everyone. And yeah, happy to, know that it will be helping you.
Okay, thank you.
Take care. Bye.